will look specifically at just the sum and difference of functions. So let f of x and g of x represent any two functions. Then we can define a new function, h of x, that is the sum of f of x and g of x. So h of x can be the sum of f of x plus g of x. So this is how you would represent it algebraically. The second way of writing it, this is just a different notation of writing it. You will see this oftentimes in the lessons. And all it really means is, because your independent variable is the same, then you can just combine the dependent variables for the same value of the independent variable. That's all that really means. So you'll either see it as f of x plus g of x, or you'll see it as f plus g of x. Both of them mean the exact same thing. The operation is what you're trying to see to understand the process you actually need to do. Okay, we can also define a new function, k of x, that is the difference of f of x and g of x. So what that looks at is subtracting f of x and g of x. And so here's the second notation of writing it. Same idea as addition, just a different way of writing it because you are looking at the same independent variable value. Okay, this is one of the definitions you'll see in your textbook, and it looks at the superposition principle. And so the superposition principle states that the sum or difference, depending on whether you're looking at adding or subtracting, so the sum or difference of two functions can be found by either adding or subtracting the y-coordinates of each point along the x-axis. So what you're looking at is, for the same value of x, you're looking at the y value of the two different functions, and you're either adding those two y values together or subtracting the two y values from each other, depending on the operation you're asked to look at. Okay? But that's essentially what the superposition principle looks at. So this is much like the G chord on a guitar example we looked at earlier. So if you remember back at the example we talked about earlier, we had three different functions. And in order to come up with the graph of the new function that actually made the sound of the G chord, what we had to do is take each of those graphs and add them together. So for example, if I look at the y value at x equal to 0.2, I have a y value of about negative 12.5. I have a y value of about 9, and I have a y value of about negative 2, let's say. And if you actually combine those three numbers together, you'll notice that it'll come up to about negative 0.2-ish. Okay? So negative 2. I apologize for that. So if I actually combine, I think I said about negative 12, plus, I believe the next number was 9, plus negative 2, you'll get something roughly along those lines. So this is going to give me negative 14, plus 9 is negative 5. So close enough. Obviously I was rounding off the numbers, but you'll notice that if I add those three numbers together, I get an answer pretty close to where this should be. Okay? These are all approximations. I didn't know the exact values. Okay, so that's the superposition principle. Essentially what you're doing is you're looking at the same value of x and you're comparing the y-coordinates, and you're either adding or subtracting the y-coordinates of the different functions. Okay? So let's take a look at some examples of combining functions graphically, and then we'll look at combining functions algebraically. So combining functions graphically. So if you are given the graph of two functions and you're asked to find the sum of it, what you would do is, for the same value of x, you would look at the y-coordinate of the first function and the second function. And what you would do in order to graph this is add these two y-coordinates together. And obviously you would need to do it for more than just a couple of points. You need to do it for several points. So, for example, at x equal to negative 1, one of the functions have a value of negative 4, the other function has a value of 2. Now if I add negative 4 plus 2, what I get is negative 2. And if you look at the graph where it's the sum of the two functions, you'll notice that at x equal to negative 1, the y value is negative 2. Okay? So if you're combining functions graphically, you're going to add or subtract the y values for the same x value and then plot the new point. You might have to do several points in order to see the shape of the graph properly. Okay? Here's another one. At x equal to 3, my y value for one of the graphs is at 4 and the other one is at 6. And 4 plus 6, if I add the functions together, gives me 10. Okay, so you'll see that this is at 10. Okay, and again, you could have done this for a bunch of points. I just chose some points that had some nice y values, but that's pretty much what you do, okay? That's if you're adding the functions together. If you're asked to subtract the functions, then obviously you would subtract the first function and the second function to get the y-coordinates of the new function you're looking at, okay? So depending on the operation that's given, you might need to add or subtract. Okay, combining functions algebraically. Now this is similar to what you saw in the warm-up. So if you're combining functions algebraically, all you really need to do is add or subtract the functions, depending on whatever the operation is that was provided. So for example, if you're given f of x equals 3x squared plus 2, and g of x equals the cosine function, so combining a quadratic and a trig function together. If it says f plus g of x, what that means is you're adding the two functions together. And so here you'll see that the first function is being added to the second function. And if you simplify it, I'm not too picky about the order that you write your terms, but obviously if you can collect like terms you want to. And in this case we can't, so we leave it the way it is. Okay. In the second example, you'll notice that it says g minus f of x. And so what that means is I'm subtracting f of x from g of x. So g of x comes first, and I'm subtracting f of x from it. And if you simplify, remember that the negative indicates that it gets applied to every term that comes after it. So negative 3x squared and negative 2. Don't forget to change your signs. And if you simplify it, that's what it essentially looks like.